Okay, so this is an exponential derivative. So to find the derivative of when you have a to the x, it's basically ln a. So you take the logarithm of the base, which is a, and multiply it by the original function again, and then you have to multiply by the derivative of the exponent. So it's not just this, you also have to remember to derive the exponent and multiply everything. So this all just becomes one term. Okay, so our first question here is find the derivative of 2 to the x. So this is in the same format as a to the x, where a is 2. So we know that the derivative of a to the x equals ln a times a to the x times the derivative of x. So if we put this into this formula, we'll have ln 2, which is just the base, times 2 to the x, which is the original function, times the derivative of x. And now the derivative of x in this case is just 1, because x is just x, and since that's just to the power 1, we just have 1. So multiply by 1 doesn't mean anything. So this is our final answer. So we can just box this in. Okay, next one we have is find the derivative of 3 to the 2x plus 1. So the first step we're going to do is find the derivative of the exponent. So the derivative of the exponent, 2x plus 1, is just 2, because just by using the power rule, this is 1 and it brings down, so it's 2, and the x to the power 1 minus 1 is 0, so x is 0 is 1. So 2, and since this is just a constant, it's just going to be 0. The derivative of any constant is just 0, so the derivative of the exponent is just 2. Now we can say ln of the base, which is 3, times the original function, 3 to the 2x plus 1, and multiply by the derivative of the exponent, which is 2. And that's the final answer. Okay, so the third one we have is find the derivative of e to the 2x minus 1. So the derivative of e to the x is actually just e to the x, because if you look at it, e to the x, the derivative, equals, so ln of the base, so ln e times e to the x times the derivative of x is just 1. And ln e is actually just 1. So this whole thing turns out to just be e to the x. So e to the x is the original function, and the derivative is the exact same thing. So let's use that to solve this. So we have ln e times the original function, e to 2x minus 1, times the derivative of the exponent, and that's just going to be 2 once again. And then we can just cut off this, because ln e is just 1. So the final derivative is 2e to the 2x minus 1. And that's the final answer. Okay, number 4, we have find dy dx if y squared plus e to the y equals 2x squared. So basically they're asking to isolate dy dx. So to do that, let's find the derivative of this entire equation. So the derivative of y squared is just 2y dy dx, because we're differentiating with respect to x, plus e to the y. Now e to the y is just going to be dy dx times e to the y. The derivative of the exponent times the original function, which is dy dx times e to the y. And now this equals, the derivative of 2x squared is just 4x. Now all we have to do is isolate dy dx. So this times 2y plus e to the y equals 4x. Now if we just divide 2y plus e to the y on both sides, And we have our answer, which is 4x all divided by 2y plus e to the y. There you go. And that's a final answer. Okay, question 5, we have find f prime of x if f of x equals e to the 5x plus 7 to the 2x plus ln of x squared plus 4. So f prime of x just basically means find the derivative of f of x. Okay, so let's first find the derivative of e to the 5x. So first thing we're going to do is find the derivative of the exponent, which is just 5. So the derivative of 5x is just 5 times the original function, e to the 5x. Now plus, this is 7 to the 2x. So we're going to do ln of the base, which is 7, and multiply by the original function, 7 to the 2x, and multiply by the derivative of the exponent, which is just 2. Now, for the last one, we have ln of x squared plus 4. So the derivative of ln x is just 1 over x, and then we multiply it by the inner function. So the inner function of x squared plus 4 is 2x, and then this is being multiplied by 1 over x. So divided by x is, so x here is x squared plus 4. So we divide it by the original function, x squared plus 4. And now I can just say the final answer, f prime of x equals 5e to the 5x plus 2 times ln 7 times 7 to the 2x plus 2x over x squared plus 4. And that's the final answer. Question 6, we have find f prime of x if f of x equals e to the tan 3x plus 6 to the x squared plus ln of secant x. So the first step we're going to do is just find the derivative of e to the tan 3x. So the derivative of tan 3x is just 3 secant squared 3x. And you can do this by just doing the chain rule of this, because the inner function is 3x, so that's why it's the derivative of 3x is 3, and the derivative of tan x is secant squared x, so and x is 3x. And then this is multiplied by e to the tan 3x. Now plus 6 to the x squared. And now the derivative of this is, first let's take the ln of the base. And now this is multiplied by the derivative, or first let's just do the inner function. So 6x squared times the derivative of the exponent, which is just 2x, plus, and then once again the derivative of ln x is 1 over x, and the derivative of secant x, which is the inner function, is secant x tan x, all divided by the inner function, which is secant x. And you can see here we can cancel out the secant x, so this can just be simplified down to tan x, because we can just cancel out the secant x on the top and bottom. And now you can just say that f prime of x equals 3 secant squared of 3x e to the tan 3x plus 2x ln 6 times 6 to the x squared plus tan x. And that's the final answer.